Hello and welcome to your first set of math content training videos. Today we will start with the basics of arithmetic. As we go through these videos, I suggest you take notes on any definitions, processes, and procedures to help you prepare to tutor students in those topics. Alright, these are the topics that we will cover in arithmetic. This video is only on integers, but we'll cover the other ones in the rest of the arithmetic videos. I recommend if you ever are struggling to remember something about a specific topic to go back and just click on that video, and it can help you prepare to help students. Alright, integers, just as a reminder, include positive numbers, 0, and negative numbers, but only whole numbers. So no fractions, no decimals, just the natural numbers, 0, and the negative counterparts. Alright, so let's start with the 4 basic operations with integers. We're mostly focusing on what happens when we throw some negatives in there. So starting with just addition. Alright, and by the way, these rules are true for integers, but they'll be true for fractions and decimals when you get negatives involved there as well. So when you add something with the same sign, it just gets even more that sign. So for example, if you add 2 positive numbers, you get a bigger positive number. You add 2 negative numbers, you get even more negative. You can think about, sadly, the weather in Rexburg, right? It's negative 3 degrees Fahrenheit outside. It goes down 4 more degrees. Now it's negative 7 degrees outside. Too cold. Yes. That's a snowflake, by the way. Alright, so same sign. Here's your very first process. When you're adding with the same sign, you add the values, whatever they are, and keep that sign, whatever it is, positive or negative. Different signs is a little bit trickier. One way you could think about it or explain it to your students is maybe we got some negative charges, negative, and some positive charges. All right, we've got 4 of those in this example. The negative and the positive will neutralize each other. We've heard people calling it canceling. So it becomes 0 or neutral charges. Whichever one is left over is the sign we still have, and there's only one of them left. So this becomes positive 1. When you're thinking about subtraction, you can think the stronger charge remains, and we subtract to see how many are left over. So on this next problem, 7 plus negative 10, the stronger one is the negative. So we know we're going to have a negative. And then we just subtract 10 minus 7, gives us 3, so negative 3. Here's our process. When you're adding with different signs, you're going to subtract the values and keep the stronger sign, whichever one has more, or whichever one is farther away from 0. 52 plus negative 7, you can think about that as 52 minus 7, and it's going to be positive, and so we'll keep that at 45. That's addition. Let's talk about subtraction. 5 minus 2, 5 plus negative 2. Okay, 5 minus 2, we're used to that. Those are positive numbers. That gives me positive 3. That's all I have left. But this, we just talked about in the last slide. 5 plus a negative 2. We subtract the values, keep the sign of the bigger. It's also positive 3. So we got the same result, but they look different, right? And they're conceptually a little bit different. That's because subtraction is a myth. Busted that myth wide open. It's really just addition in disguise. Silly subtraction. All it is, let's write it up here. Subtraction is just adding the opposite. Okay, so whenever we subtract, here's our process. Oh, I wrote on my process word. Adding with different signs, right? It's just subtraction. Whoops, that's not supposed to be there. It's supposed to say subtraction. Anyway, the rest is right. Change it to an addition problem. I told you subtraction was just adding in disguise. Change it to an addition problem, and then follow the addition rules from the last slide. So 6 minus 10 becomes 6 plus the opposite of positive 10 is negative 10. Follow the rules, that's negative 4. Negative 14 plus negative 19, right? Both signs. Keep the sign, add the values. And this is a tricky one right here. Whenever you see the minus and negative, just make that big plus sign. Negative 12 plus 5, different signs. So that's 7. Keep the stronger one. Negative 7. There you go. Moving on to multiplication. Okay, this is when the students are getting like, oh, there's a lot of rules, a lot of things going on. So let's talk about why they are the way that they are. It's my belief that if you understand the why, it's a lot easier to understand and remember the how. So let's just start with 3 times 5. Positive numbers, great place to start. One way you can think about multiplication is that there are 3 groups, and there are 5 in each group. So if you want to think about, there's 3 plates, 5 cookies on a plate, 15 cookies in total. Right? So you start out with 0, then you're going to add, multiplication always starts with 0, you're going to add positive 5 3 times. So these plus signs, those came from the 3 in the problem, and the 5 is what we're adding repeatedly. Okay, total 15. Next, what if there are negative 5 in each group? So we're just going to keep the same setup because the 3 didn't change. It's still positive 3. I'm going to have 3 plus signs. And then I'm going to add to it negative 5. Okay, if I add negative 5 to 0, that's going to go to the left on the number line. It's going to go down. It's going to decrease. It's going to go down to negative 5, negative 10, negative 15 total. But what if there were negative groups? So now it's kind of like the first one where we're going to have 3 positive 5s and start at 0. But our negative 3 is going to make these plus signs actually be minuses. I'm going to subtract. So 0 minus 5, we're back at negative 5, negative 10, and negative 15. So we're going to have the same result as the last one. Conceptually, again, a little bit different because of the placement of the negative. Now, you knew it was coming. Let's talk about a negative times a negative. This is the one that doesn't make sense to a lot of students because with addition it just becomes more negative. So why does this one turn around and become positive? Let's put together the last 2 setups that we had. Okay, we had 0, and then there was 3 negative 5s. We know we're having that from this part. And then the negative 3, instead of adding to 0, means we are subtracting. And from subtraction on the left side, we know minus and negative. These all become plus signs. It's like drawing the big old plus signs. There we go. Okay, so again, it's the same rule as subtraction. Really, this all becomes positive, and we're back at positive 15. To summarize the rules, so it's definitely something to write down. Positive, anytime you have the same sign, really. So 2 positives multiply to be a positive, so to do 2 negatives like we just talked about. Different signs, it's going to multiply to be a negative. Doesn't matter what order they're in. There's 2, 1 of each, then you're going to have a negative. Also, because of its relationship with multiplication, division follows the same rules. So if you're dividing 2 negatives, the result is a positive. All right, one more thing with integers, estimating. And estimating is really useful, not just because it's something that your students are learning in their classes, but also as a tutor, it's very useful if a student's doing a problem to just kind of think about what the answer should be close to know if you need to help them out a little bit more. So, this is a general rule we tell our students and our tutors when you're estimating to round as much as you can, round to the highest possible place value for the number, and then operate with the rounded numbers that you have. So if you're going to add, if you're going to subtract, and so forth. Let's do an example with multiplication. So I'm going to take 23,496. Its highest place value is the 10,000s place. And so I'm going to round that, looking at the 3, that's going to stay at 20,000. And then my 5,610, I'm going to round to the thousands place. Oops, underlined the wrong one. So I'll look at the 6, that's going to make it round up to 6,000. The rest becomes zeros. Now you can just multiply 2 times 6 is 12. And then Because of their place values, we're just going to count the zeros. 4, 5, 6, 7. I'm going to add those on. Alright, I'm going to add our commas if you want. 120,000. If you had actually plugged those numbers in the calculator, it'd be pretty close to that, a little under. So, it gives you a general idea of where you should be at. Alright, that's integers. Go ahead and watch the next video on fractions.